Okay, hello everybody. My name is Guy. I just finished my graduate studies at the Weizmann Institute in Israel, and I will be joining as a postdoc in the University of Berkeley sometime during this year. And I want to talk to you about something, one of the more exciting things that's happening now in astronomy. It's very exciting time for astronomy in general. As you can see, in the last few years, there's been a few Nobel Prizes and lots of interesting discoveries. But I want to focus on something that is something that's I think is very exciting, and it's the possibility of actually finding life on other planets. Um, so there's two ways to answer this question about are there life on other planets, where is it, and all of the information. And the interesting thing, I think, for me is that when I was growing up during the 90s, this thing was a question for science fiction, not for science. And it turns out in the last few decades, there's lots of answers to these questions that we didn't have just 20 or 30 years ago. And now there's really good things to say about this, that you can actually start to figure out the real answers and not just talk about it like it's science fiction. And the first part of this question is, how does life begin? We want to understand if life exists on other planets, and we have to understand how actually life started. And is it a rare process? Is it very common? What's actually behind it? And there's lots of people thinking about this. It's more towards the chemistry and the biology than it is to astronomy, but you can get a lot of useful information out of this. So for example, you have Miller's experiment where people mixed hydrogen and nitrogen and different chemicals that used to exist on the early Earth, and put some lightning bolts in there using batteries and actually tried to simulate the conditions of life on the early Earth. And they showed that you can actually get a bunch of amino acids, which are the building blocks of life. You can't get all of them from this setup, but you can get some of them, which was very promising. There's other stuff that gives you some idea about how life started, like Conway's Game of Life, which I recommend that you go to the website and look at what they're doing there. It's a very simple game where you have black and white pixels, and based on a simple set of rules, the pixels can turn from black to white. And then if you choose the right set of rules and you choose the right initial conditions, so you set up a few red and white pixels next to each other, and you start to get this behavior where these dots start moving around and replicate and do all sorts of stuff that kind of look like life. Now, it's a very simple model, but it gives you an idea that if you have chemical laws that are very complicated, sometimes spontaneously, if you put them together in the right way, you can get something very complicated coming out from relatively simple rules of chemistry and physics. So it's more of a thought experiment than a real experiment. But it gives you some kind of idea on level of the philosophy of it, that complexity can arise very easily from simple systems. And there's still a lot of problems with understanding how life started. For example, living creatures use DNA to replicate proteins, but they use proteins to actually copy the DNA from one generation to the next. And people are saying, is this a chicken and egg problem? How can you have proteins without DNA and DNA without proteins? And there's a lot of ideas going around in the community researching the beginnings of life. There are some ideas. This is very interesting stuff to read about, that I suggested you look at these links, because people are suggesting very interesting ideas how the chemistry actually initiated life. But unfortunately, nobody has really a good answer to how life started. There's a few pieces of the puzzle already, and slowly people are getting more and more ideas about how this actually happened. And of course, there's always this question of panspermia, which means that life came from another place in the universe on some asteroid where some microbes existed inside the rock, and people have showed that this can actually happen because the inside of asteroids can actually be well protected from space, and maybe some bacteria landed on Earth, and that's how life started on Earth. But of course, that doesn't solve the problem; it only moves it to some other place in the universe. So we still wonder how life actually started, and it's still an open question that we don't know the answer to definitively. But if we ask a different question, when life started on Earth, then we have much better information. We can actually start to answer this more and more precisely. And Earth formed 4.6 billion years ago, and it cooled enough about 4 billion years ago, cooled enough to have liquid water. And if you look at microfossils, so you have these little crystals that you can date using radioactive dating methods, and you can figure out when these crystals were formed. And inside these crystals, you find what you call microfossils. So just tiny little bits of stuff that looks like fossilized bacteria. And these are very, very simple life forms. So it's very hard from the fossils to understand if this is a living thing or something that looks like life, but is actually still inert chemical reactions, or it's not very easy to put the limit on this, but people say that we can actually have definitive proof that 3.5 billion years ago, there was already life on Earth, and some evidence that already 4 billion years ago, it existed. So what people are saying now, people that are researching this field, they're saying that the more you find these crystals with these microfossils, and then the more you go, deeper you go into the past, and the more research you invest in this, you find out that life started actually earlier and earlier than you thought. And it looks like life turned up on Earth just as soon as it cools. So we're talking about a few million years, which is very short compared to the billions of years that the Earth existed. And immediately life started after a very, very short time. So it looks as though if you have the right conditions for life, you immediately get life. And this is a very, very important conclusion, because if we would know that life took billions of years to start up on Earth, then we would say maybe it's a very rare thing. Maybe you have to have a lot of time and lots of different conditions to happen one after the other. And because we see this fact that life started almost immediately, it gives you the idea that probably life doesn't need a lot to get started. It just needs the right conditions, and it just starts up spontaneously and very quickly as well. And this is a little timeline just to get you into the mind frame of how long this stuff takes. So the Earth started here 4.6 billion years ago. Somewhere around here, life begins. And then you have all this time where you have very simple life. You start to get multi-cell organisms here. Somewhere around 500 million years ago, you get the Cambrian explosion, where you actually start to get animals with large bodies and multi-cell organisms, like complex life the way we know it. A big part of that is dinosaurs. And here in the last little white bit, I've expanded it here arbitrarily at 7 million years ago. And you can see that humans, I've very loosely defined them only on the last 1 million years out of this very thin sliver. And here are the 50,000 years where we've actually started to take over the entire planet, and agriculture and advanced technologies stuck here in this little red slit. So you can see that by comparison, the time that we've been technological has actually been very, very short time compared to the amount of time that humans have existed, and especially compared to the billions of years where life existed on this planet. So if you're going to find life on other planets, the biggest chance that you will have is to find simple microbial life on those planets. And only a very small fraction of those planets will have actually advanced technology. So this already puts you in the scales of the times. When I say BY, I mean billion years, and MY is million years, and so on. So let's see. So the next question we have to ask ourselves is the Earth special? Are there conditions on Earth that are unique in the universe and life exists only here? And if so, we're probably very lucky to be on Earth. So there's a few things. First of all, we're the right distance from the sun, which we call the habitable zone. And that means that we're not too far to have all the water freeze over, and we're not too close to have all the water just vaporize because of the heat. We have an atmosphere that contains all these nice elements like nitrogen, oxygen, and carbon, and you can make all these wonderful chemical compounds from them that make up our bodies. You have lots of water, and there's a big question about where the water came from, because when Earth formed, probably most of the water was vaporized by the sun, and it didn't even start up on the Earth. Some people say it's the comets, maybe it's the asteroids. I read a paper recently that says maybe the water was here all along and we just didn't know about it yet. So there's lots of different theories how the water actually came here. Some people say that you have to have a magnetic field. And there's lots of these different things, like the ozone is created by oxygen. So there's lots of different conditions. So we have to ask ourselves, how common are these systems? We know there's billions of stars in our galaxy. There's hundreds of billions of stars only in our galaxy. And we have to ask ourselves, how many of those stars have planets like Earth? How many of them do have planets at all? Solar systems in general, and how many of those solar systems have small rocky planets exactly in the right position to be not too far, not too close to their sun. So that's a big question that we have to answer. And you can say, well, maybe the Earth is the only habitable place. And that gives you another very philosophical question, which is, are we lucky? Maybe we're just lucky to be on the only habitable planet. And that doesn't really make sense, because in science, you don't believe in luck. You say, we're not in any special place in the universe. We assume that our planet is just a regular planet, but there's something called the entropic principle, which means that the only reason that we are alive on this specific planet is because the conditions were right. And if we would be unlucky to be on any other planet, then none of us would be here to be asking astronomical questions. So it sounds a little bit like an argument that fulfills itself, but it's not. It just says that conditional probability of us being on a habitable planet is actually 100%, because we have to be alive to be actually in this position. So we'll come back to the entropic principle in the end of this presentation. So let's talk about other planets in our solar system. Let's go to the nearby stuff that we have. Mercury, no atmosphere, very hot. Venus has a very hostile atmosphere. It's full of sulfuric acid. It's very, very hot. There's no water inside on the planet itself. However, there is some preliminary signs that you might have heard about of chemicals in the atmosphere of Venus that hint that there's some life going on in there. It's still not sure. Nobody knows what's really going on, but it's something new that's been published, and it's worth investigating more for sure. But as far as we know, there's no life on Venus. On Mars, maybe used to have liquid water. Right now, its atmosphere is very thin. It used to be thicker. So maybe it used to have microbial life. Right now, most likely it doesn't have any life on it. And Jupiter, Saturn, Uranus, Neptune are gas giants. No apparent solid surface. They have very dense gas atmospheres. So life as we know it probably can't exist on these planets. So, so what about the moons of these solar system planets? Let me see if there's any questions. All right, I'll take questions maybe in a little bit. So moons in the solar systems, Titan, the Saturn moon, is large enough to hold a methane atmosphere. Maybe there's different kind of life that uses methane instead of liquid methane instead of liquid water. Europa or Enceladus are moons of Jupiter and Saturn. They have a liquid water ocean underneath the ice. So it's a very interesting prospect, and people are talking about actually researching these, for example, in Enceladus, you have actually geysers shooting water up thousands of kilometers into space. When the Cassini spacecraft flew by this moon, they would see these plumes of liquid water, and you can actually start to see organic compounds in these gas plumes. And people are talking now about sending a mission to Enceladus to actually research if there's liquid water, and maybe there's life in there too. There's a few other moons that have these underground oceans or under ice oceans that all of them possibly have life under them too. We don't know. All right, so I'm going to take a couple of questions from the Q&A box right now. What was the first life seen on Earth? As I said, microfossils are just very, very simple microbial life. Very, very simple, very small. Much smaller than the cells and the complex organisms and microbes that we have today. And where did life originate? Probably in the water, maybe near deep sea vents. That's one of the theories, because the deep sea vents give off a lot of heat and energy and chemicals that could be used to start up life. What makes the Earth form? Well, that's a hard one to answer. It's a different talk altogether. Basically, gas around the sun congeals into dust particles. Dust particles start sticking together. Once they have lots of gravity, they start pulling all the other dust and rocks around them from the orbit of the Earth, and then a planet forms. That's one of the ways that people think planets form. Right, so about the Venusian atmosphere, I don't want to say too much about this because it's very new and people haven't really explored it very deeply. They know that they've seen this particular gas that's not supposed to be formed by natural processes, only by living beings, as far as we know. But since we don't understand the chemistry in Venus well enough, we can't really rule out that some weird chemical reaction actually made this without any contribution from life. So I'm not sure about this. I think it's early to be too excited, but it's definitely an interesting prospect. Other kind of life besides carbon-based, well, there's lots of options. Sure, again, I'm not going to go into this because I don't have enough time. And the atmosphere formed just along with the Earth, because once the Earth had enough gravity, it could hold on to the different gases that are accreted. Have any aliens been seen? No, not as far as I know. All right, keep the questions coming. I'm going to break for more questions soon. So let's talk about other planets outside of our own solar system, what we call exosolar planets or exoplanets for short. So the first thing you need to know about exoplanets is that in most cases, you can't actually see the planet. You just see the star as a dot of white light. And you have to figure out that a planet exists by measuring different properties of that light. So for example, you can measure the different colors coming, and if you see a change in the colors, it might tell you that there's a star moving around, a planet moving around that star. If you see a drop in the intensity of the light, like you see in this plot, where all these different dots are actually measurements of the amount of light that you see from the star, and suddenly for a few hours it drops and then comes back. So then you know that some planet, some tiny little planet is moving in front of this big star. Here in the background, what you see is a transit of a planet in our own solar system, of course, because you don't see stars this nice and big. You see just points in the sky. But this is Venus transiting our own sun, which is an interesting story on its own. And then if this happens on a faraway star, you can actually see the dip in the amount of light from that star. And then you say, ha, there's a planet. You need to have very, very precise measurements because as you can see, this little black dot hides only a very tiny fraction of the star's light. So just to give you an overview of the, what is an exoplanet? An exoplanet is just a planet around a different star than our own sun. So here you can see the history of exoplanet discovery, and you see that in the 90s, it was going very slowly. They thought they found a planet, then they found another one, and they found another one, and it was actually very rare. You had to work a lot, you had to be really lucky to find a system where the star actually is close enough and the planet is big enough and you can actually see it. And it was very rare. And then in the last decade, in 2009, NASA launched the Kepler mission. And Kepler actually started to use this method where you see the drop in the amount of light from the star. And this method turned out to be very, very useful because Kepler found thousands of stars and thousands of new planets around other stars. And one of the main conclusions from the Kepler mission is that actually the number of planets in our galaxy is very close to the number of stars. So on average, every star in the sky has a planet on average. Okay, so here's just a few examples of Kepler's planets. It found about 5,000, 2,500 confirmed. I think that number is actually growing because as the more time passes, these planets are actually confirmed to be real planets. 361 are in the habitable zone, so they're actually close enough, and not too close and not too far from their sun. There's a few examples for planets that look like our own Earth in terms of size. They're probably rocky. We don't know if they have water on them or not. But there are probably billions of such planets in the galaxy. We don't see most of them with Kepler, but we see a good sample and we can extrapolate and say that there's actually lots and lots of planets like the Earth orbiting other stars in our own galaxy. Kepler finished its mission in 2018 and another satellite is now orbiting the Earth doing something similar to Kepler with a wider field of view, looking for closer stars. And when they find these stars, then hopefully in a few years, NASA will launch the James Webb Space Telescope, which will be looking in the infrared at these planets. One of its missions is looking at these planets and actually measuring the different composition of the light coming from these planets. And then using that spectrum, you can actually figure out what kind of chemical compounds exist in the atmosphere of these planets. And you need a big telescope in space to do that, which is one of the reasons they want to launch this telescope. And with the James Webb Telescope, we will probably be able to measure for these planets if they have the chemical compounds that show you that there's life on those planets. So there's a few different biomarkers that people are looking at. For example, if you have oxygen and methane at the same time, and the different combinations of chemicals that are only created when life exists. So oxygen, for example, can be created by photosynthesis, like in plants on Earth. And if you see some of that stuff, then you can say pretty definitively that it's very likely that we're talking about life. So this is something that will be coming in the next few years. So the conclusion from this first part about life is that life forms as soon as conditions are right. Planets like Earth with the right conditions are probably very common in the galaxy. We have the technology. In the next few years, we will have the satellites in space to be actually able to find these planets and find biosignatures on them. And it is very, very likely that we'll find at least microbial signs, signs of microbial life on planets outside our solar system in the next few years, the next few decades maybe. Okay, so the big question you're probably asking yourself is, what about intelligent life? And I don't have a lot to say about this because here we don't have any definitive proof, but there are a few ideas that are worth thinking about. So stars, between the stars in our galaxy, the distance is thousands of light years. So just to move from one star to the other will take us thousands or tens of thousands or hundreds of thousands of years. But if we develop our technology in the rate that we are developing it now, we would probably have that technology in hundreds or thousands or tens of thousands of years. It doesn't really matter, because if you continue on the way we're continuing right now, we'll probably have the ability to jump from star to star, even if it takes thousands of years. And once you have one star, one planetary system around another star, you can jump from that to more planetary systems, and it turns into an exponential growth. And you can actually take over the galaxy, even if you assume that it takes a very long time, on the order of hundreds of thousands of years to jump from star to star. It will still take you, tens or hundreds of million years to take over the entire galaxy. And that's actually not a long time when you think that the galaxy has existed for 10 billion years. So the question is, where is everybody? Because if other aliens existed before us on planets that formed before the Earth, and there are planets like the Earth that formed billions of years before us, and probably some of them had life on them, probably some of them had, almost certainly had life, but at least some of them would have intelligent life like our own. And then you would say, well, if one of these civilizations is 1 billion years older than our own, they must be so advanced, they must be able to colonize the entire galaxy. We would see them on lots of stars around our galaxy. And we don't see that. We don't see any evidence, even though people are looking, and people are looking in radio waves, and people are trying to find evidence for the existence of these intelligent life. Some people say that we haven't found intelligent life here on Earth even. So it's a big question. And there's some possible explanations that I've seen. There's lots of explanations, but I'll give you a few of them. One of them is maybe they're hiding. Maybe after a few thousand years, the aliens just figured out that if they meet other life forms, then it will be bad for them or bad for the other life forms, and it's better not to meet anyone. That's an option. Maybe space exploration is just really expensive, much more difficult than we think. We think we can get to Mars, but to get to other stars is just exponentially more expensive. I don't know. Maybe we'll find that in a few thousand years. We'll discover that it's just not worth the effort. Maybe there are such civilizations just on the other side of the galaxy, and then we can't see them because they're just very far away. But again, all of these excuses are only good if you're talking about 1 or 2 alien civilizations. I find it hard to believe that many civilizations that would form in our galaxy, not one of them will have the ambition and the technology to actually take over the whole thing. So maybe we're just lucky to be the first ones. That's another option. Another less optimistic option is that they just destroy themselves. And that brings me to my conclusion. So my personal belief is that maybe the last two things are true together. So maybe most of these life forms just destroy each other, and we still haven't gotten to the point where we destroy each other. And we can still do that. We still have the option to destroy ourselves using nuclear weapons or whatever you want. So that's still an option for us. But if we do continue to exist for hundreds of thousands and millions of years in the future, maybe we'll be the first ones. And the only reason that we're lucky to not have anybody else beating us to this job of being the first ones is that, again, because of the entropic principle. Because if other aliens would have taken over the galaxy, they would already be here and explain to us all the big questions of the universe and how life started and how many life forms are in the galaxy and whatever. And then we wouldn't be here asking these questions. So maybe it's a combination of the entropic principle and maybe a little bit of the fact that most alien life forms have destroyed each other. So that kind of gives you a feeling for maybe that we have a very special role in the galaxy after all, as being the ones that still have the opportunity not to destroy ourselves. And I like to think of that as some optimistic way to look at it. But again, that's just my own personal thoughts on this. And of course, the science on this is all speculation at this point, unfortunately. But I'm going to leave you with this thought to consider it for yourselves. Thank you very much. We have time for questions. Let's see. Okay, so former life on or current life on Mars. I think if people will find fossils of life on Mars, that would be the definitive proof, because there are robots driving around on Mars looking at the soil and examining it. So if they see anything that looks like remnants of life that just in the dirt, they will find it. And I think I've answered most of these questions. Do I think it's feasible to successfully colonize Mars? Yes, I definitely think it is. I think it will happen in the next few decades that we'll start to see it, maybe a few hundreds of years, but eventually it will happen. I mean, it's not much harder than colonizing new territories during the, like 1500s. How do aliens look like? I don't know. Have humans evolved to survive on Earth? Yes, all life evolved to survive on Earth. I think that's fairly obvious thing. Can people be living underground? Yeah, that is an option. But again, I don't want to speculate too much about how these aliens live and how they exist, because we don't know. But the first thing that we do know is that we're very likely to find microbial life. This is the conclusion from where the science has brought us. Okay. Yeah, so about the number of exoplanets, I think when I wrote this slide, it was 361 exoplanets in the habitable zone. And I don't know how many we'll need to scan with the JWST to get biosignatures. That's actually the big question. So TESS is looking for planets that are on stars that are close to our star, to our solar system, so that it'll be easier to measure biosignatures using JWST. So it's an open question. I don't know the numbers at this point. I don't know if anybody knows exactly. Has anyone been on all the planets? No, human beings have been only on Earth's moon. Nobody's been to Mars yet except robots. Sorry, except robots. Robots have been to, I think, all the planets in the solar system, but human beings, no, unfortunately not. But I expect that in a few, like next 20 years, people would be on Mars, on missions to Mars, not colonizing yet, but definitely visiting Mars. On missions like they visited the moon in the Apollo missions, something of that sort. Right, wormholes, that's a good one. I don't know. There's no evidence that wormholes actually exist. Will our galaxy combine with another? Yes, probably it will combine with the Andromeda galaxy in a few billions of years. So you don't need to worry about it right now. There are a few systems where there's multiple planets in the habitable zone around the same star. It's pretty rare, but there are some examples of this. There's the TRAPPIST-1 star, which has 7 planets that, like 6 of them are in the habitable zone. So it's a very interesting system to think about. Let me see if there are any other questions. How can you find out if a planet can support life? Well, that's a good question. Again, you measure the light, you measure different frequencies, what we call spectrum, and you try to figure out if the atmosphere has the chemicals that are right to create life. And if you see signatures of chemicals that are created by life, then you know that life exists on that planet. Right now, it's very hard to tell if a planet can host life or not. But if we do see what we call smoking gun signatures that they're definitive for life, then we'll know that actually life exists, or we'll think we know. We'll have a pretty good idea that we know. Okay, I think that's it for me, right? All right, so thank you, everybody.